All right, guys, here we go. Tonight we're looking at simple nonlinear functions, all right, and what their graphs look like. There may be some of these that are linear functions, and there may be some of these that aren't linear functions. Okay, let me get on the right one here. Here's number one. Now, the math that we're going to do here is not any different than what we've done before. So this first one says consider the function y equals x squared. All right, is this a linear function? And in order to figure that out, there's a couple different ways. You can fill in the table and draw a graph, and you can look at the graph and see if it makes a straight line. If it does, then it's a linear function. If it doesn't, then obviously it's not a linear function. You can also tell by looking at the equation, and usually, I shouldn't say usually, I should say always, when you have an x squared, or an x to the third, or an x to the fourth, anything above a 1 here, that is not going to be a linear function. Okay, so I'm telling you right now, this is not going to be a linear function. But let's do some points. Let's fill in some points here. And they do ask me to find the rate of change. So I've got to figure out some points and graph it to see what this thing is going to look like. All right. Now, I am not going to take these 4 exercises and put all the math down for all of these points, all right? That you can do on your calculator or you can do on a piece of paper. So I don't want to take, a half an hour, 30, 35 minutes on this video by writing down all of the math that goes on, because it really is the same thing over and over, all right? But let's fill in some values. And I'm not even going to go, let's see how many we got here. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's start with -4 up here. Okay. And let's just go by ones. And we'll see what will fit on this graph next door here. Okay. Now I'll do the first one here. Y equals -4. If I'm going to plug in a -4, and then I'm going to square that. All right. And that's just simply -4 squared, which gives me a 16. Okay, so a 16 is going to go right here. Well, that's not going to fit on this graph. So if I continue down the line and I plug in a -3 and I square it, I get a 9. So I'm going to get a bunch of points here. This is going to be a 4. This is going to be a 1. All right, and I'm just doing these real quick. All right, if you want to check my math on the calculator, go for it. Okay, but this is what they're going to end up giving you as values. All right, and these, of course, are all points that we can graph. All right, so let's graph what we can on this coordinate axes over here. All right, here's my x-axis, here's my y-axis, and let's put in here -4 comma 16 is not going to fit, but -3 comma 9 will fit. Okay, and -2 comma 4 will fit. -1, 1 is here. 0, 0 is here. Let's see what we got. 1, 1 being here. 2, 4. And you can see it starts to get symmetrical about the y-axis here. So I'm going to try to sketch this in. All right. I'm going to do real short little strokes here so I can try to get a good graph here. I don't want to be too far off. But as you can see, that is definitely not going to be a straight line there. Okay, so this actually we call a parabola or a parabolic shape. Okay, so that you can add to your repertoire of words to know, right? So anyway, so that's pretty straightforward. Just plugging in the numbers and getting an answer there, getting a matching y for that x, or input output like we've been talking. All right, but it says find the rate of change. Now the rate of change, we've said for a while now, that is really the same thing as your slope. Okay, so I'm going to use my slope equation. All right, we'll put it right there. And I'm going to use my slope equation to find the slope between various points. All right, so let's just take these two right here. All right, no rhyme or reason. I'm just going to take those 2 points right there. And my slope is going to be 9 minus 4 over -2 minus a -3. Okay, so be careful with your positives and negatives there. I'm going to get 5 over, let's see, negative 2 minus, I actually need another minus in there. Negative 2 minus a negative 3, that is going to give me a 1. So my slope there is 5. All right. Let's take my slope in another couple points. Let's go right there. All right. Again, no rhyme or reason. I'm just picking those out of the blue here. So let's do that. So let's see. That'd be 4 minus 1 over 2 minus 1. Okay. And I get a slope of a 3. Okay. Notice this is not a linear function. Okay. So we should put that in there. Not linear. Okay, we can tell by the equation because of this squared. We can tell by the graph because that certainly does not look like a line. Okay, and here's another way we can tell. We can also tell it's not linear because these are different. All right, and if you had a linear function, those would both come up to be the same. Okay, we'll do one more. We'll do these two right here. And let's see, what would that be? 25 minus 16 over 5 minus 4, and we're going to get 9 over 1, which is a 9. Again, it comes up different. So, moral of this story, right? The slope of a non-linear function is not always the same at different places on the graph. All right, and that kind of makes sense if you really understand what slope is. This is much steeper. This is much steeper right in here than it is in here, in that section right there. All right. Okay, so that's exercise 1. Let me get things cleared off, and we'll go into exercise 2. Okay, guys, here's number 2. This is basically asking us to do the same thing. So immediately I look at this and I see this x squared. All right, so that's telling me that this is going to be, whoops, don't want to do that. This is going to be a non-linear function here. Let me get that green thing out of there. All right, there we go. All right, so this is definitely going to be a non-linear function because of that squared. But let's go ahead and let's put in some values for x and y here. All right, now if I look quickly ahead, these values are going to get pretty big pretty fast because you're going to be squaring some things. So let's start here at negative 2. All right, and let's go by ones again. And let's put in 2 and 3. And let's see how far I want to go. Let's just go up to 3. All right, let's just do that many. And if I plug in a negative 2, all right, make sure you go by your order of operations here, because if you don't, you're really going to get, you're going to get a wrong answer. All right, so the first thing we need to do is square the negative 2, and that gives me a positive 4. Okay, and 2 times 4, that's going to give me 8. And let's see, 8 plus 3 is going to be 11 there. All right, and I'm going to basically do the same thing for each one of these values here. Plug in a negative 1, it's going to square and give me a 1. And when I multiply it by a 2, it's going to give me 2, and I'm going to add 3, and I'm going to get a 5 right in here. All right, when I plug in a 0, I'm going to get a 3. And when I plug in a 1, I'm going to get a 5. When I plug in a 2, I'm going to get an 11. And then when I plug in a 3, and this is why I stopped at 3, I'm going to go up to 21. So that definitely is not going to fit on this graph over here. All right, so here's my x and y axis. And I'm going to go ahead and graph some of these. Now, negative 2, 11, I'm going to throw that one in here just because I know it's going to be right there, but I really wouldn't need to. Let's see, negative 1, 5 is going to be right there. 0, 3 is going to be right there. 1, 5 is going to be right there. And let's see, 2, 11 is going to be way over here. Okay, so then I'm going to connect those, and you're not going to get a line. All right, it's going to be definitely like a parabolic shape there. Okay, so what do we have here? We have a parabola type shape, and they want us to do the same thing, find the rate of change. Again, that is just the slope. Okay, so again, your slope equation here, we'll throw that right there. Okay, and if I figure out my slope for a couple of points, let's do these two right here. It should not come up the same because this is nonlinear, so my slope is going to be 11 minus -2 over a 5 minus a -1. And let's see what I get here. 13 over 6, which I'm not even going to reduce that. All right, that's going to be like 2 point something. All right, and let's compare it to this one right here. Let's go, how about these two? All right, let's go m equals 11 minus 5, and that would be a 2 over 1. So what is that going to be? 6 over 1, and that's going to be a 6. So definitely, all right, up here we get like 2 point something. Okay, and this being a 6, those are definitely not the same. All right, so let's go ahead to number 3 here. Let me get this one off of here. And it says, consider this function. Is this linear? Now, I do not see a squared or a raised to the third or anything like that. So I have my suspicions this could be a linear function, but let's check it out. All right, let's plug in some values for x here, and let's see, which do I want to use here? Some of them are going to be some good values, some of them are going to be some bad values. So let's see what happens here. I'm going to plug in, how about we start with something a little smaller? How about we start with a -5, and we just go by ones here. And what's that going to be? 0, 1, 2, 3, 4. Okay, so we can get up to 4. Let me make that a little better. And let's start plugging in some numbers here. And I plug in a -5 right there. And if I take 1 and divide by -5, I get, oh, what do I get? I get a -0.2. All right. Well, I can live with that number. All right, so this is -0.2 here. Okay, and I plug in a -4. Well, 1/4 is 0.25, so that's a -0.25. Okay. You see the numbers are very different here, but that's okay. It's just going with the formula here. All right, let's plug in a -3. That's going to be -0.3 repeating. I'm not going to put the little repeating symbol. I'm just going to go, oh, we're going to round that to the 10th. Okay. And if I plug in a -2, well, that's -0.5. I'm getting somewhere. Stick with me here. Y equals 1 over -1. That's -1. Okay, hey, that's a cool number. I like that number. Okay, now here's the one I want you to see. If I plug in a 0 here, take your calculator. All right, take your calculator and plug in. Let me move it over here. Oops, I don't want to do that. I want to move this. Oops, we lost our calculator. Here we go. All right, let's move this guy. And let's go 1 divided by 0. And what do I get? Uh-oh. I cannot divide by 0. Okay, here's where this function falls apart. You cannot divide by 0. So you do not get a 0. You get nothing. You destroy space and time. Everything falls apart and blows up. I don't know what. All right, you cannot divide by 0. So this is not a 0. It's nothing. It does not exist. All right, a lot of times we put DNE, baby. Does not exist. Okay, so that point right there is not, it's not going to work. Okay, we just can't put anything in for there. All right, then we fill in the others here. You get a 1 here, you get a 0.5 there, you get a 0.3 repeating there, you get a 0.25 there. Okay. All right, now what if we went ahead and we graphed these? -5. This is going to be really close to the x-axis here. So you know what? I'm going to change the scale. I'm going to go by 0.1s. Okay, 0.1. So this is going to be in my y direction. This is going to be 0.1. This is going to be 0.2. It's going to be 0.3, etc. Okay, so I'm going by 0.1s along here, and I'm going to do the same thing: -0.1, -0.2, -0.3, etc. Okay, that's going to make it a little easier to graph here. All right. So -5. These are still going in the x direction. We're still going by 1. So -0.2 is going to be here. -4, -0.25 is going to be there. All right. -3 is going to be there. All right. What do we got? -2, -0.5. Uh-oh. Look at that, dipped way down to here. All right. So what's that? -2? Yep, right there. Okay, and -1. Well, 1 would be all the way down to here if I went by 0.5s. So look at when you start to sketch that. Look at what happens here. All right, that is definitely not a line, and that's a pretty bad sketch right there. This is gonna take that right out of there. All right, that is a pretty bad sketch. Okay, let's see if I can do a little better here. That curves, there we go, curves way down. All right, and actually, oh, what did I do? I put that in the wrong spot. All right, take that out of there, Mr. Martell. What are you doing? You skipped one. All right, take this out. Get rid of it. All right, let's fix that one. Okay, this one goes here, and this one should actually go here, right? -1, 1. All right, and then we sketch that, and that's going to go down. Now you get to trig. A few years from now, you're going to talk about asymptotes, okay? And you get to trig, and you're going to talk about this where it comes down here, and it doesn't quite touch the x-axis or the y-axis, sorry, but it definitely gets really close, okay? And if I did this other side, 1, 1, where's 1, 1 would be way up here, all right? And 2, 0.5 would be about here. And let's see, 3, 0.3 is going to be here. And what do we got? 4, 0.25, that's going to be about here. And then 5 would have been 0.2. And so you can see this is going to curve again. So is it linear? Even though it didn't have any x squareds, this is also not a linear function. Okay, so there you have it. All right, now let's do some slopes right here. I'm just going to pick 2 of the slopes again. All right, we're going to take let's take these 2 right here, and we'll pick, oh, I don't know, we'll take these 2 right there. Okay, so the first one's, let's see, that's going to be -0.25 minus a -0.2, and that's going to be over -4 minus a -5. I'm going to squeeze negative in there. All right, and if I bring up my calculator, I'm not going to bring it up on the screen. Let's just go, let's see, -0.25 minus a -0.2. I'm going to get a -0.05. Okay, and then we're going to go -5 minus a -5. That's actually going to give me a +1. So my slope there is -0.05. All right, and if I do the other slope with these red, let's put it right down here. That's going to be 0.3 minus 0.5, and that is going to be 3 minus 2. So what is that? -0.2 over 1. All right, and those are definitely not the same value. All right, that is -0.2. Okay, so you can see that the slopes did not come up the same. All right, guys, here's number 4, and this is, again, very similar. Now, I went ahead and I changed my scale on my graph because I know these are going to get really big really fast. All right, so if you want to go ahead and put your x and y axis here, the x values I'm still going by 1s in the x direction, but in the y direction I'm going by 10s. All right, so if you need to pause the video, that's fine, but I'm going to go ahead and fill in some values, and you can see if I put in a -3 in for this one, that means I'm taking negative 3 times negative 3 times negative 3. That automatically gets me up to a negative 27. All right, whoops. And that we're going to take times 2. So you actually get negative 54 for this one. All right, and you see, just going to 3, you already get up to 54. If you went to 4, if like we put them in negative 50, put a negative 4 in there, you'd be up to negative 128 because of that cubing right there. That makes it go up really fast, really quick. All right, so I'm going to go ahead and fill in the other values. If I plug in a negative 2, I get a negative 16 as my answer, and I get a negative 2 here. I get a 0, which that's pretty cool. That's pretty easy. All right, and I get a 2, and then a 16, and a 54. So I want to see the graph of this one. This graph of this one changes really fast, really quick. Okay, so here's 0, 0. That one's pretty easy to graph. Negative 1, negative 2 is going to squeeze in right there. But then watch what happens when I go to negative 2. It really jumps down to there. And then when I go to negative 3, it jumps all the way down to here. Okay? So that is definitely not a linear function. Okay? You can see it kind of curve right there. Okay? And if I do the other side, it does the same thing. 1 comma 2 is there. 216 is here, and 354 would be way up here. So it goes like this. Hold on, it goes like that. All right, so that is definitely not linear. Okay, and just like we did with the others, let's do a couple of slopes. We can pick these two right here, and I'll do these two. Let's take these two right here. Okay, I was going to take these two, but really it's kind of like the same number there, so I want to take some that are different. So what's my slope? Negative 2 minus a negative 16 over negative 1 minus a negative 2. Okay, and if I subtract those, that is going to give me an 18. And negative 1, actually plus 2 is going to give me 3. So my slope there is 6. And my slope in between these two numbers is going to be 2 minus 0 over 1 minus 0, which is just going to be 2 over 1, which is 2. Okay, so again, you can see that the slopes do not come up the same. All right, so there's your 4 examples. It really was the same thing in all 4. So hopefully that went well. So thanks for watching, and we'll see you tomorrow.